All right. Good morning, everybody. Yesterday, what we did was multiplying polynomials. So today, it seemed like a lot of people, maybe half or more of you as a group, were all a little bit iffy yesterday on it. So I thought today we would review multiplying polynomials, and we're going to take a little look at the next lesson. So it's kind of a half and half day. I want to review yesterday's and then get our feet wet, just starting the new material, which is called um, factoring polynomials. Okay, so also, I apologize. I thought I uploaded yesterday's video yesterday, and the truth is I didn't. I realized it this morning, so I edited it a little bit, cut it down, and then uploaded it this morning. So if you still need to see yesterday's lesson, you should be able to see it now on the YouTube link. All right, so today we're going to call this review multiplying polynomials. I'm just going to say polys, review multiplying polynomials, and beginning factoring. Two topics for today, review multiplying polynomials, and we'll look at beginning factoring. Any questions or concerns at all, please? Okay. All right, so let's start with some practice and review. Do these with me, and let's see if it's helpful to just spend more time on our multiplying polynomials. So let's do example one. Let's say we had 2x times 3x plus 4. So the outside term, in this case, the outside term is 2x. That needs to be multiplied to every term on the inside of the parentheses. We're distributing it to everything inside. Now, whole numbers, stuff like the 2, 3, 4, those are going to get multiplied together as if there were no x's at all. And then for terms that have variables or x's, those need to be multiplied together too. And how we represent the x's or any variable will be using exponents. So please take a moment and try to multiply these together. And if you feel ready to share with me and with the group what you got, I'd like to hear from you and we'll talk about it. So take a moment and try to do this multiplication and let me know if you'd be willing to share.
You want the answer?
If you don't mind.
6x, the exponent is 2 plus 8x.
Very good. 6x to the second power plus 8x. High five from far away. Boom. Thank you for sharing. Since you did share, would you mind helping me out and explain how you got these numbers? You're correct, by the way, 100%. But would you mind telling me where'd you get the 6? How come this is x squared or x to the second power? And then where'd the 8 come from?
I took out the constants, the x's and stuff.
Uh-huh.
And I did 2 times 3, which is 6, and then I used your product rule, the x times x equals that, and then you add the variables. But it was no variables, so 1 plus 1 is 2.
Good.
And then that brought me to 6x2 plus 2x times 4,
Mm-hmm.
and then I just times 2x and 4. and I got 8x.
Thank you so much.
You're welcome.
That was wonderful. And I love that you even dropped in there the product rule. Very good. That's technically what we're doing when we stack up our exponents, like we did in this problem, x times x, that became x squared, or x to the second power. And what do we call that? The product rule. Beautiful. Anyone else have any other comments or anything they noticed about this problem they'd like to share? Or questions? No. Okay, let's try another. Example 2. Okay, I'm gonna just try to bump it up a notch with each one and make it a little more complex. Some of the ones we did yesterday were crazy, I admit, but I wanted you to be ready because some of those really crazy ones were in the mastery test. So, but here's another one. Let's just do one step at a time in complexity. Negative 5x squared times, make a nice big parentheses there, times x squared plus 2. Again, take a moment, try multiplying these out on your own, and then we will talk about them. If anyone's willing to share, I would love to hear from you. And we'll do it together. If you can answer it for me, I would really appreciate that. Or if you just want to try, or if you want to just get me started, any input from you is greatly welcomed.
I have the answer.
Okay, go for it. Is that Manaya?
Yeah.
Okay, go for it, Manaya.
Negative 5x to the fourth power. Negative 10x to the second power.
Beautiful. Okay, and so well done. Yeah, I think this is 100% correct. It looks good to me. I think of it as that outside term needs to be like individually multiplied to all those inside parts. And that's what Manaya did this time. So negative 5 times whatever the first coefficient is, just a 1. And so that's why we have a negative 5 here. Negative 5 times that positive 2 gave us the negative 10 down below. And then don't forget about your x's or whatever variable is in the problem. So we've got x squared times x squared. And if we look at that up close to the side here, using that product rule again, 2 plus 2, how many total x's is that? It's 4 x's, x to the fourth. And then the x squared multiplied to the plus 2, thus solo lonely 2, well, there's still an x squared going over there, right? Being multiplied. So that's why we have a single x squared, or x to the second power, for our answer. Great. Thanks, Manaya. Any other comments or questions on this example? Okay. Let's look at number 3. And you know what? We'll just keep up 2 here. I'm going to do number 3 right below. All right, let's bump it up a notch and try doing 2 binomials multiplied together. X plus 3 times x plus 4. Now, this might look intimidating. Pretend for a second that it was just, and watch my screen if you're not already, what I'm going to do is cover up part of the problem, deal with half of the problem, and then we'll kind of uncover it and do the second half of the problem. So this x plus 3, just pretend for a moment that there was no plus 3. So I'm just going to cover that up with my finger, so to speak. Now my problem is just x times x plus 4. This is not too bad. This is just like example 1 and 2. So we would get x times x and x times 4. So let's do just those below. X to the second power plus 4x. And now I want to uncover my plus 3 and deal with that. I haven't dealt with that yet. So now it's 3 times x and 3 times 4. So that gives me a plus 3x and plus 12. Any questions or concerns so far on this multiplying or distribution? Go for it.
Did we get the x when we multiplied the x with x and 4?
Correct.
How we got 4x? Okay.
Correct, yes. And then that's the same thing that happened with how we got 3x.
Oh, okay. Thank you.
Does that help, Braden?
Yeah, one more. Actually, how did we get the plus 12, actually? How did we do that?
Because we have the constant 3 and then the constant 4. Those got multiplied together at the very last multiplication.
Oh, okay. Thank you.
Absolutely. So there's our answer. However, it's very common, folks, for there to be like terms that we can add or subtract. And you might have noticed that this problem has them. We've got x to the second power. There's no more x to the second power. So it's kind of safe. There's no more we can do with that. I'm going to copy that down below. And 4x and 3x, those two terms, though, those are like terms, right? They match their variables. So we can add them. 4x's plus 3x's for a total of 7x's. So those are combining to make 7x. And then lastly, our plus 12, he's lonely. There's no more whole numbers to add or subtract to that thing. So I'm going to bring down the plus 12. And now we're done. So just be wary. Doing the multiplication, we want to be comfortable with that. But then we also have to be wary, we might have to add or subtract some of these terms together after we do that initial multiplying. So make sure that you're always in the mindset of, I'm going to scan through and look for, is there any more adding to do here? Is there any more subtracting to do here? Any other questions or concerns, please? Okay, let's try another one. We saw one like this yesterday. This will be example 4. It's binomial squared. So let's do this. X minus 7 parentheses. So we're going to kind of group that together as a single binomial, x minus 7. And that's going to be raised to the second power. So this doesn't look like a multiplication problem right now. But remember, what does the second power mean? It means the entire base multiplied to itself. So this example is really x minus 7 times x minus 7. And now it looks kind of like example 3. Two binomials multiplied together. So now we need to multiply the first x by everything in the second parentheses, and then that minus 7 by everything in the second parentheses. So one step at a time. X times x, that's x to the second power. X times negative 7, that'll be negative 7x. Now we're done with that first round of multiplying, but we've got to deal with this guy, the negative 7 in that first parentheses. Now he's going to be multiplied to everything on the right. So we have negative 7x again, and then negative 7 times negative 7. Negative times a negative makes positive. 7 times 7 makes 49. And again, we have an x term and another x term. So that's like saying negative 7 minus 7. Digging us deeper down into negative territory with negative 14x. No more adding or subtracting we can do. No more like terms, so we're done. Okay. No comments coming in, no questions. Let's do another one. Let's do another one like this. That was number 4. Example 5.
Wait, so Josiah, that was the answer for number 4?
Correct,
example
Leja.
4?
Yeah,
Okay. Just making sure. Thank you.
absolutely. No worries. There's our answer. I want to give you guys kind of a heads up or like a hint maybe. I don't mean to make anything more confusing. That's never my goal. However, a lot of the work we're going to be doing in Math 2, or at least definitely in this unit and next unit, is going to be going from a form like this one. So I'm going to make a fresh example here to demonstrate what I'm trying to say. So here's example 5. And this is where we're going to be doing a lot of work, where it looks like this. X plus, let's make up a new one, x plus 10 times x minus 4. So notice what this looks like. X plus a number, x plus or minus a number. They're being multiplied together, right? And then when we're done, we'll do the actual multiplying in a moment. But when we're all done, we're going to have a form that looks like this. And where A, B, and C are just like some numbers, okay? But it's going to be this format. Some number x squared plus another number x plus a constant c. This is where our main focus is. And this is where I'm trying to get you all most comfortable, is multiplying two binomials together and then getting some final answer that'll always look like this, much like example 4 did and number 3 did. Now, let's try multiplying these out and see what the answer actually is for example 5. Did anyone finish it yet? Would anyone like to share what they got? Or even if you've just done part of it?
You want the answer?
Yes, answer or just partial if that's all you got. Whatever you got.
X to the second power plus 6x negative 40?
Negative 40. Okay, so Manaya's got the final answer here.
Oh, that's right?
Looks good to me, yeah. Let's double check it. Is that okay?
Yeah.
Okay, so there's Manaya's, and I do think you're 100% correct on that, Manaya. Let's work it out real quick together, and everyone can kind of compare notes. Let me change my color. So here I'm going to work it out in red now. So x times x. That should be x squared. X times -4. -4x. And now we're all done here with that guy, with that single x. Now we're going to shift over to the plus 10, and that's going to get multiplied to everything in the second parentheses. So 10 times x plus 10x, and 10 times -4 gives us the -40. And hopefully you're starting to see how those middle two terms are always going to add together. When we're doing a binomial times a binomial, like we did here in the last two examples. And that's where Manaya got her plus 6. We've got -4x plus 10x. So these two folks in the middle combine to make a 6x. So we've got x squared plus 6x minus 40. And now, since I've written it this way, look at our final answer in red there, or the one Manaya gave us, same thing. Compare that to the top, ax squared plus bx plus c. So in our problem for number 5, the a place, the a like term is 1. Okay, because what number is being multiplied to that x squared? There's nothing there. So we would say that the a term here is 1. What's the b term here? 6. It's being multiplied to that single x. And our c term is -40. I just want you to start looking at your answers this way as the A, the B, and the C numbers. Comment, please. Any questions or comments so far? Okay, let me switch over and see thumbs. I'd like to see how people are feeling about this, and maybe do a poll if you'd like to do more multiplying binomials like this, or are people feeling ready to start looking at factoring? We're probably not going to finish all the factoring today, but I thought we could just begin it. So let's see thumbs. How are we feeling on these last 5 examples? Aaron, thank you for your feedback.
I feel good about it, but my camera is not working still.
Okay, Manaya, thank you. And Delaney, I see that. Braden, I see that. Thank you, guys. How's everyone else feeling? Keegan, Janessa, Jayla, Sai, Leja, Hunter.
I feel fine.
I see something in the chat. Okay. So we're kind of mixed again like yesterday as far as our comfort level. Bailey, thank you. I see you there. Let's do maybe 2 more for now, and then let's start looking at factoring. Okay, and like always, guys, and folks, I should say, if you have questions or concerns or comments, just jump in. Turn on your mic and tell me, Josiah, what are you doing? I don't understand. Or Josiah, back up, slow down. It's okay. I want us to be collaborating on this. So example 6. Okay, let's try this. Let's do another one with 2 positives. So let's do x plus 5 times x plus 7. X plus 5 times x plus 7. We should be seeing 4 different multiplications, at least to start us off. And just one moment, folks, I got a visit from the principal. So
I just need to poke my head in real quick.
Of course, no worries.
Right out of your hair.
Can I possibly help you with anything?
You know, just I thought we had a biohazard waste container.
Maybe down here, but I don't think I saw it.
I feel like it would be
This is where I would have hidden it if we did
like kind of red. Yeah, that's not
highlight
bad.
stuff.
Yeah. Okay. Thank you.
Yeah. Okay, so like I was yammering about, we should have 4 multiplications. So think about it as like we've got items in the first parentheses, right? And then we've got items in the second. Um, I like to go down the list of items in the first parentheses. So we've got our x here, and we've got the 5. So we should see x times everything in the second parentheses, and when that's done, 5 times everything in the second parentheses. I'll go ahead and write out all 4 like we were yesterday. So x times x, hopefully this is looking familiar, gives us x squared. X times 7, 7x. Now we're done with that initial x. We're done with it. But we're on to the 5. 5 times x. And just so you know, I'm multiplying the 5 to that x in the second parentheses. 5 times that is 5x. And 5 times 7 gives us 35. And just like we've seen in the last few, those 2 center terms are going to add together because they're both x numbers. So pay attention to their signs, right? Sometimes they're negative, sometimes they're positive. But basically, no matter what number they are, no matter what the sign is, we're going to crash them together for one x term. So that'll be 12x this time. So final answer here is x squared plus 12x plus 35. Started with these 2 binomials, and now we've ended with a quadratic trinomial. And like I was saying earlier, this is where most of our work in Math 2 is going to be, at least in this fall semester for sure. Polynomials that look just like this, quadratics. So that's why I decided let's slow down a little bit. Let's not rush this. Let's take our time with multiplying these out together until everyone's feeling better. And that's it for example 6. Any questions or concerns? To look at our answer here, x squared plus 12x plus 35 in the ABC format, I'm just going to throw that in since I've started that conversation now. A is 1. B is the coefficient in the middle, the x coefficient, or the plain x coefficient, so B is 12. And then C is always that whole number at the end. This time it's positive 35. All right, let's try one more together, and then we'll take a brief look at what factoring is for polynomials. Okay, so example 7. A quick question, is this cut off for anybody? Can everyone see my example 7 in the top left corner?
Yeah.
Manaya's good. Is anyone else having trouble seeing my screen, this presentation?
No, I can see it.
Okay. All right. If anyone is, please let me know. Leja, thank you. Okay. All right, let's try another one. Let's see what I started making up new ones off the that I didn't write down, so I don't want to repeat. Let's try, we'll throw a negative in here. In fact, let's do 2 negatives. Let's do x minus 2. X minus 2 times x minus 20. X minus 2 times x minus 20. I'm going to give you a few moments to try doing it on your own, and then we'll look at it together.
Okay, I have the answer.
Sorry, what was that?
I have the answer.
Go for it, Manaya. Thank you.
X to the second power minus 22x plus 40.
Plus 40. Very good. Very good, Manaya. Do you want to walk us through step by step on that one?
Yeah, sure.
Okay, go for it.
So I got the x2 because there's two x's, so that'll be x to the second power. And then I did x times 2, which is 2, and then x times 20 is 20. And then
And were those negatives or positives?
negatives.
Okay, so for each one, we had a negative in there, -2,
Yeah.
-20. Cool.
And then I did 20 times 2, which is 40, and then I added the -20 and the -2, and it got me 22, -22. And then I added the x to the 22.
Very good. Very good. Thank you, Anaya, for sharing. Any questions or concerns about what she did here? Notice that the multiplying for the -2, -20, two negatives multiplied together and gave us that positive 40 at the end. But the middle term is -22x. Why is that? Because if you look back where she got those parts, it was a positive times a negative, -2x, and a positive times a negative, -20x. And then we added two negative numbers, right? They were both negative. It went further down to 22, -22. And then if you want to look at this as ABC format, it's also called standard form of a quadratic. And I wasn't planning to get into that today, but I've already started. So let's just continue, keep it fresh in our minds. What's the number being multiplied to the x squared? Kind of a trick question. Anyone want to take a stab at that? What's the coefficient of x squared in this answer?
Isn't it the 2?
The 2 you're saying, that's our exponent.
Okay.
What's so I am kind of being tricky here. Is there a number being multiplied to the x squared?
Oh,
No, right? So what could we say is there since there's no obvious number there?
1.
A 1. You got it, because 1 times x squared is x squared. So in a tricky way, we're saying that our a value, our a place is 1. How about the b? Anyone want to take a stab at that? What's the middle coefficient we see here?
Isn't it 22x?
It's correct, and it's just the coefficient, just the number itself. So
Oh, just 22?
yes, correct. So 22, and in this case, it's minus 22. So we're going to say it's negative 22. It's the whatever sign is with it. We're going to bring that down as our B, or our A, or our C. And then for C, it's that constant 40, positive 40. This will come into play a little more importantly later, but I want you to just start thinking about the A, B, and C terms now. So our answer, folks, is what Manaya told us already, that polynomial. That's our solution. That's our answer. However, what those numbers are important, and we're going to use those tomorrow and Thursday and next week and probably the rest of this semester. So start thinking about what is the A number, what is the B number, what is the C number. Any other questions right now? Concerns? We've been doing this for 30 minutes. Let's switch gears a little bit and look at factoring. All right, here we go. So, what is factoring? You've heard this already before in math in different ways, probably, or like different contexts. What it means for us is undoing distribution. Write this down. Factoring is undoing distribution. So it's basically undoing all the work we just did on the first 7 examples. For the first 7 examples today, we've been multiplying. It's some number or term multiplied to a bunch of stuff in a parentheses. Now I want to start talking about, well, how would we undo that if we needed to? So let's start with this. example, now I've lost count because let's see, this is number 8. Let me just change this on my paper quick. Okay, so example 8. We begin with this expression, 4x squared plus 4x. My question to you, looking at both of these terms, what is common between the first term and the second term? What are the same items that you see that we could divide out of both of these terms? Notice that, and the terms we're looking at here, this is term 1, and then term 2 is 4x. So examining both of these, they both have a 4. See that? So if we needed to, we could take away the 4 from both because they both have it. We're looking for any items that they share in common. Let me write that down. When we're doing factoring, I'm going to put this at the top. We're looking for items or terms that both, that all parts or all terms share. Or have in common. Sorry about that writing. We're looking for items, terms that all of the given terms share. So in this case, both of these terms have 4. Is there anything else that they each have?
X.
Yes. Do they both have 2 x's or do they both have 1 x?
1x.
Very good. Yeah. Our first term is x squared. So remember, what does that mean? 4x squared. If you broke that apart into a long string of multiplication, like undid the exponent kind of, this is 4 times x times x. Our second term, we can see just has a single x. So they each share a single x. So these both have a 4 and a single x. Okay, so once we've identified what they both have, then what we're going to do is divide out, kind of pull out from each one of those a 4 and an x. So here's how we do that. So at the bottom, we're pulling out 4 from both, and we're pulling out x from both. And I'm going to put a parenthesis here without anything inside it yet. And our question now is, what's left over from term 1 and term 2 if I pull out a 4 and I pull out an x? So looking at term 1, the 4 would be gone and a single x would be gone, leaving 1x. So that goes for the first spot in my parentheses, a single x. Looking at term 2, if I pull out 4 and x, well, there's nothing left. But if you're dividing it out, it would look like this, 4x divided by 4x. And of course, you know that means 1. Anything divided by itself is 1. So what's left for that second term? The number 1.
Plus.
Sorry, I covered you. What was that?
Oh, no, I was just saying the answer.
Totally, yeah. So we have 4x times x plus 1. So what we've just done is we've factored this expression, 4x squared plus 4x in blue. We factored it, and now it is a multiplication problem, right? It's like the other direction from what we've been doing so far in our multiplying. We've undone the distribution. Any comments or concerns or questions? Okay, let's try another one. Number 9. Now, remember what we're doing here is trying to undo distribution. So we've got 10x squared plus 2x. Our first question is, what do they have in common? What could I divide out from both of these terms? And then we have to divide it out and show what would be left over from both terms after dividing out what's common. We were doing factor trees in this group last week and the week before. It can be helpful to make factor trees with your coefficients to see what's common to divide out. If you don't see it initially, it might be helpful to do a factor tree. 10, for instance, is equal to 2 times 5. So now I see, oh, they both share a 2, a times 2. So you could divide out 2 from both of these. I'm going to kind of set up my answer below. I'm going to pull out a 2, and like last example, we're going to pull out an x. They each share at least one x. And now I think that's it. What would be left over after dividing out 2x from each of these?
5x plus 1.
5x plus 1. Manaya, you are on it today. Very good. Thank you. Any other comments? I'm kind of writing this with a lot of space, hopefully to make it clear. But what this means, though, folks, is 2x times. Don't forget that these are being multiplied. My 2x is right up on the parentheses, being multiplied to 5x plus 1. But we're not going to multiply it. We want to factor it. So here we would be done. This is our solution. Let's look at another. Number 10. All right, this time I'm going to bump it up a notch. X to the 5th power minus 20, x to the 3rd power. Factor this expression. Our format, what your answer should look like, is going to be a sum term multiplied to a parentheses. And inside is going to be 2 terms. Like this. So we're looking for what are we pulling out, and then what's left over in those parentheses after we've taken it out.
So you want the answer?
Are you ready?
Yeah, I think I got it right.
What'd you get?
X to the 3rd power for the first spot, and then in parentheses, x to the 2nd power minus 20.
Very good. Yep. Very good. This time, all we could take out was the x to the 3rd. And that happens sometimes. There was no coefficient, no number to take. And that's okay. Manaya went through and she said, okay, I don't have a 20. I can't take a 20 from each of these. Or a 2, or a 10, or a 5, or anything. But I can take out x to the 3rd from both of these. And what's left over? X to the 2nd power minus 20. Okay, no questions. Let's try another one. Example 11. Let's do 3x to the 2nd plus 9x. Factor. Here's the format.
You could do 3x.
We can take out 3x this time. Perfect. And what are we looking at left over after taking out that 3x?
X plus 3.
X plus 3. Now, I want to show you guys a quick thing if you're wondering, how are they finding these leftovers? I didn't really show you this yet or delineate it, but once you identify what you can take out of each term, so in this case, what can we take out? We took out 3x. This is our first question to ask yourself doing a factoring problem. What can we take out? 3x in this case. Now I want you to take each term from the beginning and like literally divide it by 3x and see what's left over. Let's do that here. So 3x squared, that's the first term, divided by 3x. Cancel and simplify your exponents. That's why we've been doing exponent work in Unit 1. 3 over 3, those canceled out. And then what is this? The difference rule for exponents. So 2 minus 1 is left over as x to the first, x to the 1. And that's why we have a single x in that spot in the parentheses. Now 9x over 3x. X is canceled, and 9 over 3 is 3. So first step is identify what you can pull out. And then second step is literally divide all those original terms by what you're pulling out. And that'll tell you what goes inside the parentheses. All right. (15x to the second power minus 10x).
Do you want the answer?
Are you ready?
Yeah. I
Okay.
think I really got this one wrong though.
Let me know what you got.
5x parentheses 3x minus 2.
Yes. Very good. Very good. So I wanted you all to see sometimes we can't take out like the entire coefficient. We can't divide 15 from both of these terms. We can't divide 10 from both of these terms. But we could take out 5 from both of these terms, and that'll happen sometimes. Okay. I want to show you one thing just so you start thinking about it. And then we'll do, I guess, 6 questions for homework today. No mastery test. If you haven't tried yesterday's mastery test, I'd like you to do that today. That was multiplying polynomials. Okay, so where we're going to be going with this is just to start thinking about it now. What we want to do ultimately is be given a polynomial in ABC form, like this. X squared plus, sorry, just one second. X squared plus 7x plus 10. And this is where we're going. We're not doing this example right now, but we'll be doing this Thursday and next week. If you were given a polynomial like this, a quadratic, our goal is to factor this to like its original form, where it's x plus something times x plus something. This is where we're heading. This is, honestly, I think one of the main points of Math 2. And we're going to be starting this probably tomorrow and Thursday, and then next week as well, this whole unit. Before we get there, I thought we should slow down a little bit and just practice our multiplying and practice the factoring that we did today, just pulling out a monomial from binomials. But that's where we're heading. Let's do 6 questions for homework. Okay, what is today? Today is the 28th. So let's do 3 questions on multiplying. So for number 1, multiply 3x times x plus 7. And let's do x plus 5, x plus 10. Number 3, multiply some negatives. X minus 4 times x plus 2. All right, there's our first 3 problems. And now for some factoring problems, let's try number 4. Factor x to the second plus 5x. If anyone needs me to read these out because I'm not writing it very clear, please tell me. Let's see, number 5 will be, let's do 20x squared plus 15x. And then 6, and last one, let's do 10x to the 6th power minus 5x to the 4th power. 6 problems for homework. No mastery test today. If you haven't done yesterday's mastery test, start catching up on that. Try it out. Give it a shot. Another announcement, this afternoon, 3 o'clock, is my office hours. So if you want to go over any of this work in our class, come join me at our regular link at 3 o'clock. If you haven't written these down, I want you to take a picture. And I want you to do these 6 problems today. We'll go over them briefly tomorrow. But then you'll take a picture of your finished work and send it to me as an assignment. So this is an official assignment for the class. This is due for Unit 2. Any questions? Concerns?
How many have you assigned us so far?
You said how many assignments or what are they so far?
Yeah.
Totally. So far for Unit 2, we've just got mastery test number 1, multiplying polys, and this 6 questions from today.
Okay.
So far in Unit 2, homework is mastery test 1. That's multiplying polys. And then this 6 questions from today, which is this lesson is a mixed lesson. I'm calling it review multiplying polys and beginning factoring. I will have our video up today. I'm not going to let it go till tomorrow, so I apologize for that. If you need to see yesterday's lesson, it is up now.
Josiah,
Yeah,
we can send the homework through Remind, right?
of course.
Because sometimes like if I were to like to send a picture or whatever to like Megan or my other teacher, it won't send or it would be like not delivered.
Well, if that's not working, if you get a not delivered message, then maybe you can email it to me instead of
Mhm.
Remind. Or are you using Google Chat with any of your teachers?
No.
Google Chat is super easy. And honestly, it works better than Remind because you don't have to for me, if I want to send you guys a picture on Remind, I've got to like download it and then upload it one picture at a time. And on Google Chat, you can just cut and paste. So it's just a little faster and smoother. Google Chat looks like this because you all have Google accounts already. Like even if you don't use it, let me show you. Okay, so if you're in any Google like app thing, here's my calendar. Up at the top right, the little 9-dot menu deal. If you click on that and then scroll down, look for this green one called Chat. You can add me in this chat, super easy. All you got to do is, let's see, you would go up here, do the plus sign for like a new chat, and type in my email, which is my name, Josiah Henderson, at ofy.org. If you do this to me, then it'll kind of open up a thread. And then anytime you need to send homework, you can just put it in this Google Chat. Some people have been doing this. And
Mhm.
Remind's good. If it works, I'm good with Remind. But if you're having trouble with it, email it or do this instead.
Okay, for sure. Thank you.
Yeah. And let me just really quick check you guys off.
Mhm.
Saeed, Aaron, Bailey, Hunter Delaney. Bailey, Hunter Delaney. Braden, Leja, Manaya. Braden. Manaya. Saeed, Keegan, Janessa, Jayla. Keegan, Janessa, Jayla. Okay, Angelina, no. Noah Sanchez, no. All right, I guess that's everything. All right. Any other questions? Stick around. Otherwise, you're all free to go. Thank you so much for coming, and I hope today was useful. I'll see you tomorrow. We'll do more factoring.
Thank you, Josiah. Have a wonderful day.
You too. Bye, Aaron.